Hello. After a summer break, I'm delighted to welcome you to a new St. John's Pipecast. Our subject today is the geologist, paleontologist, and natural theologian William Buckland. Now, Buckland was the most eminent scientist in 19th century Oxford and its most impressive lecturer, holding readerships in both mineralogy and geology. He was also a prominent churchman, being a canon of Christ Church Cathedral and later Dean of Westminster. Buckland did a huge amount to popularise geology and paleontology, serving as founder and president of the British Association for the Advancement of Science and also of the Geological Society. He is credited with the first formal identification of a dinosaur, the Megalosaurus, in 1823, and the first public lecture on dinosaurs in Oxford in 1832. He was on close terms with the Prime Minister Robert Peel and also Prince Albert. Yet despite his prominent role in British intellectual life, Buckland is less well known today, and three factors have limited, I think, his influence. First, he was a proponent of the natural theological tradition at a time when that tradition was facing eclipse. Second, he lectured in Oxford in science at a time when science had a very marginal position within the university. And thirdly, in 1849, he suffered a mental breakdown and drifted into insanity by the time of his death in 1856. Today I want to sketch some of the leading features of Buckland's career and situate him within the wider context of Oxford and science in the early 19th century. Now, when the 19th century began, the dominant tradition within thinking about the physical world was that of natural theology. Gaining its full expression in William Paley's 1802 book, Natural Theology, it contended that the world revealed the handiwork of God, and to study nature was indeed to study God. Science and religion were in harmony, and where religion disclosed the wisdom of goodness of God through Scripture, science revealed his wisdom through the study of his works. The 1830s saw a final flourishing of this tradition in the Bridgewater Treatises, a series of works commissioned by the Earl of Bridgewater in 1829 and designed to exalt the power, wisdom and goodness of God as manifested in the creation. But this happy union between science and religion was increasingly threatened, and three questions were especially troubling. First, how old was the Earth, and how had it got to be the way that it was? How did mountains come to be, and rivers, and valleys, and rocks? Now, theologians have pondered these questions for centuries. In 1650, Archbishop Usher had concluded, from the genealogies of the descendants of Adam and Eve, that the Earth had been created on the 22nd of October, 4004 BC. But geologists began to suspect that the Earth was far older than this. The German Abraham Werner put forward the idea that the Earth was made up of a series of rock formations, rising from older primary rocks through secondary and tertiary, the primary rocks being laid down by a vast ocean at least 1 million years ago. A Scotsman, James Hutton, speculated the Earth had been formed over multiple millions of years. There is, he wrote, no vestige of a beginning and no prospect of an end. A second problem was the Great Flood. Had there really been a huge deluge that had covered the entire Earth and destroyed all living creatures, except those saved in Noah's Ark? Was there any evidence for such a catastrophe? surely a mass of animal and human remains would mark its occurrence, but none had yet been found. Was it even plausible that all the Earth's species could have found space in a large wooden boat? Thirdly, there's the problem of fossils. Amongst the rocks were remains of creatures that existed long years ago and bore little resemblance to the animals known in the world today. Had there been then another kind of world before the one that now existed? And if so, why had the Bible not mentioned it? And how was it that the remains of animals associated with the tropics were to be found in the northern temperate zones? Had they been carried there by the Great Flood? Or had the whole world gone through vast changes in climate and land use, with seas giving place to land, only to be succeeded by seas again? Such were the perplexing problems confronting natural theologians in the early 19th century, and no one wrestled more vigorously with these questions than William Buckland in Oxford. Now, born in Axminster in Devon in 1784, Buckland was the son of the Reverend Charles Buckland, who encouraged his son's interest in nature and geology. At 14, he went to Winchester College, and then in 1801 to Corpus Christi College in Oxford, where he studied classics and theology. After graduating in 1804, he began to indulge in his passion for geology. He attended Kidd's lectures in mineralogy and chemistry, and Sir Christopher Pegg's on anatomy, and took walks on Shotover Hill with William Broderick, an undergraduate with a considerable knowledge of geology. In 1809, Buckland was ordained into the Church of England and became a Fellow of Corpus. His rooms became notorious for the jumbled heaps of rocks and fossils that would characterise his living quarters for the rest of his life. Sir Roderick Murchison recalled his first visit to Buckland. I can never forget the scene that awaited me. Having, by the direction of the janitor, climbed up a narrow staircase, I entered a long corridor-like room, which was filled with rocks, shells, and bones in dire confusion. And in a sort of sanctum at the end was my friend, in his black gown, looking like a necromancer, sitting on one rickety chair covered with some fossils, and clearing out a fossil bone from the matrix. And it wasn't rocks and fossils alone that shared his rooms. There were cages filled with snakes and frogs in the dining room, while guinea pigs roamed free. A fellow Don remembered the perils of a visit to Buckland's rooms. I took care to tuck up my legs on the sofa, for fear of a casual bite from a jackal that was wandering round the room. And when I heard the animal munching up something under the sofa, and was relieved that he should have found something to occupy him, I told Buckland. "My poor guinea pigs," he exclaimed, and sure enough, 4 of the 5 of them had perished. Buckland was a passionate and gifted geologist, but he was also a vigorous networker, cultivating contacts in the government and court. In 1813, the Prime Minister, Lord Liverpool, appointed Buckland to a readership in mineralogy, and to this was added in 1818 a readership in geology. Now, 2 things are particularly important in shaping Buckland's reputation at this point. First, his striking talent as a lecturer, and second, his defence of the natural theological tradition. Now, Buckland was one of 19th century Oxford's most powerful personalities. His lectures were an event. A naturally ebullient personality, his lectures were tactile and humorous, full of energy, jokes, pictures, stories and exhibits. They drew a crowd. Henry Ackland described attending a Buckland lecture. He paced like a Franciscan preacher up and down behind a long showcase of 2 steps in a room in the old Clarendon building. He had in his hand a huge hyena's skull. He suddenly dashed down the steps, rushed, skull in hand, at the first undergraduate on the front bench and shouted, "What rules the world?" The youth, terrified, threw himself against the back of the seat and answered not a word. He rushed in on me, pointing the hyena full in my face. "What rules the world?" "Haven't an idea," I said. "The stomach, sir," he cried, again mounting his rostrum. "The stomach rules the world. The great ones eat the less, and the less the lesser still." Now we have a drawing of Buckland lecturing in the Ashmolean Museum in Broad Street in 1823, surrounded by maps, drawings, fossils, animal bones, and holding up a large ammonite fossil. In the audience were many of the leading Oxford figures of the day, including several heads of colleges. Oxford dons were aware of the importance of the emerging science of geology and the study of ancient fossils and its implications for theology, and they were keen to know more. Geology was at this point the most exciting academic discipline in Oxford. "It's impossible," said Colonel Portland of the Geological Society, "to convey to the mind of anyone who had not heard Dr. Buckland speak the inimitable effect of that union of the most playful fancy with the most profound reflections which so eminently characterized his scientific oratory." However, the more observant among you, I think, may notice that in the picture of Buckland's lecture there were no students. This is because in Oxford, in the first decades of the 19th century, hardly any students studied science at all. The dominant study was classics, and there were no exams in science. Hence, students had no incentive to attend science lectures. And add to this the fact that at Oxford in those days, you had to pay to attend a course of lectures. Few students wanted to pay £2 to attend Buckland's lectures in geology when there was no exam in the subject. The result was low and declining attendance at science lectures. Between 1822 and 1830, the average number of students attending Dubonet's chemistry lectures was 28. In the 1830s, it fell to 14. Attendance at Kidd's anatomy lectures fell from 29 to 17, while those signing up for Rigauld's experimental philosophy class went from 42 before 1830 to just 8. Now this was important. Professors were expected to top up their incomes from the fees they charged for their lectures, and for many these fees were so small it was barely worth lecturing at all. With attendance at his chemistry lectures falling down to 10 in 1838, Dubonet cancelled his course for 1839. So Buckland didn't just want to entertain, he needed to draw a fee-paying audience. And in this he was successful, at least for a time. His geology lectures drew audiences of around 40, rising to a peak of 90 in 1825. Combined with the 30 or so who attended his mineralogy lectures, this brought in a combined income of £200 per annum, effectively doubling his professorial salary. Now, what made Buckland so important in 19th century Oxford is that he was a churchman as well as a scientist. Oxford Fellows were worried about how this new geology would fit with the old religion, and Buckland was the man to do this. He thought that geology and religion were complements, and that geology was the master science in which God revealed himself upon the earth. Thus, in his 1819 inaugural lecture as reader in Geology, Vindicae Geologicae, or the connection of geology with religion explained, he showed how the study of geology has a tendency to confirm the evidences of natural religion, and that the facts developed by it are consistent with the accounts of the creation. In particular, evidence confirmed the accuracy of the biblical narrative of a great flood, which swept the earth and exempted only such people and creatures as Noah saved in his ark. This explained while fossil evidence suggested that Britain had once been home to animals, like hyenas and elephants, which no longer survived. Buckland followed up this idea in his 1823 book, Reliquiae Diluvianae, or Observations on the Organic Remains contained in Caves, Fissures, and Diluvial Gravel, and other geological phenomena attending to the action of a universal deluge. While recognising that the Earth was considerably older than had previously been believed, he argued that this was compatible with Genesis accounts of creation, which affixed no date for the beginning of the universe. But the geological evidence suggested the Bible was right to talk of a vast deluge covering the earth within human history. In everything that I've been able to observe myself, or to collect from others whose opinions on such subjects I most highly respect, I find a series of numerous and widely varied facts, a certain class of which bears as unequivocal evidence to the existence of a deluge at or near the period assigned to it by Moses. Among such evidence was the distribution of quartz pebbles and gravels across the south of England, the location of boulders, the shape of river valleys, and the near universal distribution of mud, together with the fossils of now extinct animals. Now, while Philip Shuttleworth, a fellow of New College, might quip, "Some doubts were once expressed about the flood. Buckland arose, and all was clear as mud," the book was in fact a great success, and the first and second editions quickly sold out. Buckland also made clear his rejection of evolutionary ideas, which were just about beginning to emerge at this time. God had made the world as it was, and had done so to prepare it for man, his last creation, who was of relatively recent date. The world was certainly not shaped independently of God, making itself through evolution. I am not quarrelling or finding fault with a crocodile. A crocodile is a very respectable person in his way. But I quarrel with finding man a crocodile superior. We shall not be degraded from our high estate, to say to that reptile crocodile, "Trust and greet you well, right loving cousin." Fossils of ancient creatures were manifestations of the great chain of being. They were not stages in the development of species. Each was created by God once and for all, and then some were rendered extinct through a series of catastrophes by which God acted upon the earth. There was a progress of types, in the sense of a hierarchy of complexity of organic types, with man at the pinnacle. But there was no progress from one type to another. Buckland then fitted admirably the religious-shaped mental universe of the early 19th century, and his career went from strength to strength. In 1825, he was appointed a canon of Christ Church Cathedral. Now, few inhabitants of Christ Church's Tom Quad can have been more rumbustious than Buckland and his large family. Tuckwell recalled how, as a child, I was wont to play with Buckland's son Frank and his brother in their home at the corner of Tom Quad. The entrance hall with its grinning monsters on the low staircase, the side table in the dining room covered with fossils, paws off in large letters on a protecting card, the very sideboard candlesticks perched on saurian vertebrae, the queer dishes garnishing the dinner table, horseflesh I remember more than once, crocodile another day, mice baked in batter on a third, while the guinea pig under the table inquiringly nibbled at your infantine toes, the bear walked round your chair and rasped your hand with file-like tongue, the jackal's fiendish yell close by came through the open window, and the monkey's hairy arm extended itself suddenly over your shoulder to annex your fruit and walnuts. Buckland was notorious for his attempts to eat his way through the animal kingdom. While Hedgehog was apparently good and tender, Crocodile was judged an utter failure. His bear, named Tiglath-Pileser, named after the founder of the Assyrian Empire, became a well-known Oxford character. At one garden party in the Botanical Gardens, he arrived dressed up as a student, complete with cap and gown. Buckland was now one of Britain's foremost scientists. In 1829, he was made president of the Geological Society, and in 1832 became the first president of the British Association for the Advancement of Science, hosting the association's first public gathering at Oxford in that year. Those attending included the Duke of Sussex, whom Buckland hosted at Christ Church, Michael Faraday, the physicist David Brewster, and John Dalton, the pioneer of atomic theory. Buckland delivered a lecture on the Megatherium, the first public lecture in Britain on the subject of dinosaurs. It contained his trademark mixture of science and humour, and the geologist Charles Lyell was impressed. Buckland was really powerful last night on the Megatherium. A lecture of an hour before a crowded audience, standing room only for a third. Lots of anatomists there. The gigantic bones exhibited. Buckland made out that the beast lived on the ground by scratching for yams and potatoes. As he was as big as an elephant, the notion that he burrowed underground must be abandoned. He concluded with pointing out that as the structure of the sloth was beautifully fitted for the purposes for which he was intended, so was the Megatherium for his habits. It was the best thing I ever heard Buckland do. He also led an excursion to his old stamping ground on Shotover Hill. At the conclusion of the gathering, the geologist Adam Sedgwick paid tribute to Buckland. All who have witnessed the exercise of his great powers combine with extraordinary tact and temper, so that through his governing influence the jarring elements of a society not yet organised have been brought to order and harmony, must have been struck with admiration. During the long philosophic banquet of which they had been partaking while in his presence, all seemed to have been living in intellectual sunshine. Buckland then exerted a powerful influence, not just within Oxford, but upon a wider national and even international stage. But notwithstanding Buckland's breezy confidence that geology and theology were natural bedfellows, tensions between the two approaches to the world steadily widened, and even Buckland faced increasing difficulties in reconciling the two. One problem was the lack of human fossils within the diluvial deposits. Buckland had located evidence of the action of floodwaters in the geological record and then inferred that this was the deluge ascribed to the time of Noah. But the biblical deluge had destroyed not only most of the animals, but nearly all humans too. It was surprising then that no human remains were found in the geological record of the flood. Buckland's deluge must have predated the biblical deluge, dating from a time when humans did not exist. But if Buckland's deluge predated the biblical one, then there was no evidence for the biblical deluge at all. Dinosaurs were another problem. That temperate lands like Britain had once been roamed by animals like elephants, lions and hyenas was well known, and numerous fossils had been uncovered. It was believed that these exotic creatures had been destroyed in the Great Flood, and their bones thus preserved. But in the Ashmolean Museum were a mass of much larger bones. And what was puzzling about these bones was first, that they came from much deeper down in the earth. They had been uncovered below 40 feet of solid rock. How could they have got there? And second, they didn't seem to be the bones of mammals. They were those of a reptile. The closest living parallels were crocodile and monitor lizard, but these creatures were on a far larger scale. Buckland was at first reluctant to explore this issue. He had just been appointed reader of geology, and part of his pitch for that position had been his commitment to reconciling geology with natural theology. It was hardly a propitious moment to announce the existence of a massive 40-foot lizard of whose existence the Bible contained not a hint. But meanwhile, a doctor in Sussex, Gideon Mantell, had uncovered the fossilised remains of a tropical forest. And amongst these remains he discovered the bones and teeth of a large, unknown creature, what in fact proved to be the iguanodon. Unfortunately, Mantell was much less established in the scientific world than was Buckland, and his discoveries were left in relative obscurity. And still Buckland said nothing publicly about his giant bones. Only in 1823, when news of Mantell's giant bones began to percolate into the national press, did Buckland feel compelled to go public with his findings, or lose credit for the discovery of the new type of creature. And so, in February 1824, Buckland laid before the Geological Society samples of the giant bones, which he conjectured came from a large lizard, which he named the Megalosaurus, or giant lizard. It was the first land-based dinosaur to be named, and is now known as Megalosaurus bucklandi, and it helped form the basis upon which in 1841 Richard Owen was to identify the class of dinosaur, or terrible lizard. Mantell was in the audience of Buckland's talk, and when the speaker stopped for questions, Mantell related his own discoveries of large fossilised teeth and bones, some of which were even bigger than Buckland's. Realising now the importance of Mantell's collection, Buckland travelled to Lewes to inspect it and to visit the Cookfield quarry. Thus, when Buckland wrote up his paper on the Megalosaurus, he paid tribute to Mantell's work and estimated that his Megalosaurus was up to twice as large as the Oxford specimen. But dinosaurs were not the only challenge to Buckland's attempts to reconcile science with religion. His own theory of the biblical deluge was also under mounting pressure. Ironically, some of this was the result of his own pioneering research. In 1821, Buckland journeyed to Kirkdale, near York, to inspect a cave which had been found to contain a large mass of bones. What he found upon removing the mud at the bottom of the cave were hundreds of teeth and bones from animals such as elephants, rhinoceros and hyenas. What did it all mean? Buckland's skillful deductions from the evidence won him in 1822 the Royal Society's Copley Medal. Scarcely a bone has escaped fracture, and on some of the bones marks may be traced, which, on applying one to the other, appear exactly to fit the form of the canine teeth of the hyena that occur in the cave. The hyena's bones have been broken and apparently gnawed equally with those of the other animals. Not one skull is to be found entire. Fragments of jawbones are by no means common. The ordinary fate of the jawbones, as of all the rest, appears to have been to be broken to pieces and swallowed, the teeth being rejected as too hard for mastication and without marrow. The greatest number of teeth are those of hyenas and the Ruminariae. It is probable that the cave at Kirkdale was, during a long succession of years, inhabited by a den of hyenas, and that they dragged into its recesses the other animal bodies, whose remains are found mixed indiscriminately with their own. It was a brilliant piece of analysis, yet its implications were troubling for diluvial interpretations of the British geological record. Caves containing bones of exotic and large creatures had been found before, and it had been assumed that they had been washed into the caves by the swirling waters of the Great Flood. But Buckland's discovery suggested that such creatures like elephants, rhinoceros, tigers and hyenas had been native in Britain for many years, which in turn suggested that the climate had once been very different. Buckland did not yet relinquish his model of the deluge, and he suggested that the world of the hyenas had been swept away by the Great Flood, which accounted for the covering of mud in the cave at a date like 6,000 years ago. One of his students was prompted to write a poem regarding the fate of the last English hyena. High on a rock, which over the raging flood reared its bleak crag, the last hyena stood. Beneath his paws a kindred skull was seen, and he with commons short looked grim and lean. But ere it rose to mix him with the rest, thus did he growl aloud his last bequest. My skull to William Buckland I bequeath. He moaned, an ocean's wave he sank beneath. But did the last hyena thus perish beneath the biblical deluge? Doubts mounted. Buckland's former student Lyell led the way. Lyell argued that rivers in the past operated as rivers do today. They cut valleys, not in some powerful storm surge, but by gradual erosion. In support of his ideas, he drew upon his geological observations in the region of Auvergne in France. Here he found gravels of the kind Buckland had attributed to the Great Flood, but they lay beneath volcanic rock. The problem with this was that the volcanic rock had itself been cut with river valleys. So clearly, if the Great Flood laid down the gravel, it could also not explain the valleys. The streams themselves must have produced this by gradual erosion. Now Lyell pursued this line of reasoning with a vengeance. Complaining that England was more parson-ridden than any country in Europe except Spain, he resolved to free science from Moses. He accumulated more and more evidence that the Earth's surface had been moulded over millions of years by continually operating processes, rivers cutting valleys, sediments building up in deltas and ocean floors, earthquakes and volcanic eruptions, wind, rain and ice. Within Lyell's uniformitarian model, there was no need to evoke global catastrophes, like the biblical flood. And as the earth evolved in its character, so did the plants and animals that inhabited it. While some species thrived, others became extinct if they could no longer adapt. Now these ideas, of course, pointed the way towards evolution. And it was no accident that Darwin took a copy of Lyell's 1830 Principles of Geology on his voyage in the Beagle. Buckland retreated before Lyell's arguments. He abandoned plans for a second edition of his book, Relics of the Deluge, and by the 1830s gave up his attempt to explain the deposits of gravel, stones and boulders in terms of a great flood. Although at first resisting the theory of his friend, the Swiss geologist Louis Agassiz that the dispersal of these deposits, and indeed the contours of the landscape, was shaped by glaciation, by the end of the 1830s he was being won over to this explanation. In 1840, Buckland and Agassiz travelled to Scotland, and they found, reported Buckland, abundant traces of glaciers around Ben Nevis. The agility with which Buckland relinquished his previous beliefs concerning the processes that shaped the Earth's surface reflected to his credit as an open-minded scientist. Yet it could not obscure the fact that a crucial part of the biblical interpretation of the history of the Earth had thereby been abandoned. Buckland's greatest attempt to reconcile science with religion was his 1836 Bridgewater treatise entitled Geology and Mineralogy, considered with reference to natural theology. Commissioned in 1830, it took him 6 years to complete, and he worked intensely upon it late into the night with his wife Mary, who provided many of the illustrations. The assumption from which Buckland began was that the world had been made by a wise and good creator. The history of the earth afforded proof of the repeated interventions of a divine creator, who made a world ever more perfect for man. The layers of rocks out of which the earth was formed, and the record of fossils of extinct creatures, prove that the organic forms which once inhabited the earth were constructed with a view to the varying conditions of the surface of the earth, and to its gradually increasing capabilities of sustaining more complex forms of organic life, advancing through successive stages of perfection. Most conclusive in this regard for Buckland were the anatomical laws discovered by Cuvier, who showed how creatures widely varying in time and appearance were yet constituted by structural similarities of organisation which could only point to the designing hand of a god. Wherever we look in the fossil record, we find a numerical coincidence and a concurrence of proportions which it seems impossible to refer to the effect of accident, and which point to a unity of purpose and deliberate design in some intelligent first cause from which they are all derived. We find too evidence of God's wisdom and care for the world. While some regarded dinosaurs, such as the Megalosaurus, as evidence of mistakes in nature, Buckland's conviction of a divine design would not allow for botched creatures, and he showed how the dinosaur's feet and teeth were perfectly adapted to the environment within which it lived. Even the existence of carnivorous animals, which seemed incongruous for a God of love, fulfilled a part of the divine purpose, for by quickly dispatching old or weak animals, the sum of suffering on the earth was reduced. Buckland's conclusion represents a last flourishing of the natural theological tradition, and I quote, "The whole course of the inquiry, which we've now conducted to its close, has shown that the physical history of our globe, in which some have seen only waste and disorder and confusion, teems with endless examples of economy and order and design, and the result of all our researches, carried back through the unwritten records of past time, has been to fix more steadily our assurance of the existence of one supreme creator of all things, to exalt more highly our conviction of the immensity of his perfections, of his might and majesty, his wisdom and goodness, and all-sustaining providence, and to penetrate our understanding with a profound and sensible perception of the high veneration man's intellect owes to God." Buckland's work was warmly welcomed. The first edition soon sold out, The Tory Quarterly Review called it a most instructive and interesting volume, whose pages proclaimed the universal agency throughout all time of one all-directing, all-pervading mind, and which would swell the chorus in which all creation hymns his praise, and be a witness to his unlimited power, wisdom, and benevolence. Now, while many in Oxford resented Buckland's geological obsessions, and not a few regarded his theology as heretical, it was hard to vouchsafe that he had done all within his power to show Oxford and the world that the latest science could be reconciled with the tenets of religion. It was an achievement of international significance, and in 1845 his friend Robert Peel appointed Buckland Dean of Westminster Cathedral. But by this point, even so star performer as Buckland was unable to escape the downward drift in the numbers of students attending science lectures at Oxford. By the late 1830s, attendance at Buckland's lecture was in the mid-20s. In the early 40s, it was down to 15, and by the later 1840s, was barely above 10. His last geology and mineralogy lectures in 1850 drew a mere 11 and 7 students, respectively. It was a far cry from the packed lecture halls of the early 1820s. By now the glamour of the new geology, just opening up as it was the age of dinosaurs, had passed, and Buckland himself was no longer resident in Oxford. The degree to which Buckland was disheartened by this decline in interest in his lectures was revealed in 1847, when Henry Ackland and Charles Dubonnet requested that he add his support to their campaign for the building of a natural history museum in Oxford. Buckland's reply killed the project, at least until the 1850s. Some years ago I was sanguine, as you are now, as to the possibility of natural history making some progress in Oxford. But I have long come to the conclusion that it is utterly hopeless. The idle part of the young men will do nothing, and the studious portion will throw their attention into the channels of honours and profits, which can alone be gained by the staple subjects of examinations for degrees and fellowships. At present, it is a detriment to a candidate for either to have given any portion of his time and attention to objects so alien from what is thought to be the proper business of university, as natural history in any of its branches. I therefore return the paper, which I think it would be useless mockery to put my name to. During 1849, Buckland sank into gloom and depression. He became agitated, beating his head, scratching himself. Physicians had no cure except to recommend the fresh air and peace of the countryside. Buckland moved to Islip, the church living connected with the deanery of Westminster, where he was visited by such old friends as Owen, Conybeare, and Faraday. But nothing would rouse him from his torpor, and he would read only the Leisure Hour and the Bible. When his frantic outbursts became more and more extravagant, he was moved to John Bush's mental asylum in Clapham, where he died in 1856, aged 73. He was buried in the churchyard at Islip. Busts of Buckland were placed in the south aisle of Westminster Abbey and in the Oxford Museum. Was Buckland's collapse into madness the product of a conflicted personality? Was he simply no longer able to sustain the contradictions of a life of faith and a life of science, especially as the advances in the latter overwhelmed one bulwark of religion after another, threatening to submerge the whole as comprehensively as Buckland's celebrated deluge? The relentless onslaught of new evidence, suggests Cadbury, the endless attempts to breach an unbridgeable gap, seem to have finally taken their toll. Such an explanation is not entirely implausible. There was always something a bit manic about Buckland, Marianne Sommer has drawn attention to the coarse humour of his lectures, attributing his relentless propensity to mingle science with humour as a coping mechanism. Whenever the implications of a geological discovery cast an ominous shadow over biblical teaching, Buckland would lighten the atmosphere with a joke, leaving his audience puzzled as to whether he was serious or not. Buckland endeavoured to create a conceptual space, he thinks, between geology and theology, and one of his strategies of negotiation was a rhetoric that lingered between the serious and the ironic, allowing him to retreat when retreat was found necessary. Balancing conflicting ideas through exuberance must have taken a toll upon Buckland, and one which, possibly, as he entered his late 60s, he may have struggled to sustain. Even so, it seems that this was not the cause of his final insanity. After his death, it was found that the base of his skull and 2 upper vertebrae were in an advanced state of decay, the result of a carriage accident involving himself and his wife on a visit to Germany. Although both recovered at the time, the head injuries they sustained were responsible for a degenerative effect upon their brains and helped to cause their deaths, Mary dying only 1 year after her husband. 30 years earlier, his friend Richard Watley of Oriel College had penned a mock elegy for Buckland, and the words remained as fitting as they ever had been. Mourn, Ammonites, mourn over his funeral urn, whose neck ye must grace no more. Nice granite and slate he settled your date, and his ye must now deplore. Weep, caverns, weep with unfiltering drip, your recesses he'll cease to explore. For mineral veins and organic remains, no stratum again will he bore. The fact that even so brilliant a comet as Buckland could blaze across the Oxford sky in the 1820s and 30s, only to fade in the 1840s and terminate in a Clapham lunatic asylum, seemed to sum up the dolorous state of Oxford science in the first half of the 19th century. In retrospect, Buckland appears something of an oddity. He was a great scientist, a pioneer of the new sciences of geology and paleontology of international reputation. He was also a tremendous personality, probably the most dynamic individual in 19th century Oxford. Yet each of these qualities embodied a contradiction. His science was impressive, despite the fact that he operated within a paradigm that was fast becoming obsolete as he wrote. He assumed that God made and governed the world, and he took it for granted that the great flood of the Bible was true. But as the contradictory evidence mounted, he relinquished his initial attachment to the idea of a great deluge. Yet he did not relinquish his conviction that God shaped the world for man. Instead, he pushed on with a brusque, unflagging energy, using humour and restless motion to reconcile the developing contradictions within his own worldview. While we may reject the idea that these tensions precipitated his madness, there is no doubt that his performances were becoming increasingly anachronistic, and it was almost fitting that he died 3 years before Darwin's Origin of Species, since it's hard to know how the author of the Bridgewater Treatise would have come to terms with evolution. When confronted with evolutionary theories previously, he had deployed humour to discount them. Whether these jokes would do muster again to preserve the natural theological tradition must be doubted. Samuel Wilberforce's question to Thomas Huxley as to whether he would rather be descended from an ape on his grandmother's or his grandfather's side exposed the inadequacy of humour as an argumentative strategy by the 1860s. But there's another sense in which Buckland is an outlier. He was a great Oxford scientist at a time when there was hardly any science in Oxford. Again, Buckland surmounted this contradiction by the power of his personality. He made people come to his lectures by their unmissable brilliance. But overall, his academic legacy within Oxford was limited. By the time he lost his mind, he was, within Oxford, a forgotten figure, lecturing to a mere handful of students. One individual, however impressive, could not overcome the indifference towards science of an Oxford still wedded intellectually to ancient history and theology. For us today, Buckland is perhaps most relevant as a study in charisma, the power of charisma to overcome contradictions and make a world, and the limitations of charisma when pitted against a zeitgeist which, whether in the form of Oxford's preoccupation with religion or science's tendency to discard natural theology, moved in ways that Buckland could not easily accommodate. Thank you.